Hello children. So today I'm again with your physics lesson. So we'll be starting a new unit today called light. So as per your ICSE syllabus, okay, your unit B, that is light, okay, consists of three different chapters. That is chapter number 4 as per your book, refraction of light at plane surface, refraction of light through lens, and the 6th chapter is your spectrum. So there are 3 chapters, okay, under this unit which you have to prepare. All right, now let's see the marks distribution. From these 3 chapters you will get 6 marks question, which is compulsory in your section 1, and in section 2 question number 6 will be coming from your section 2, getting 10 marks. So in total from this unit you will be getting 16 marks question. 6 marks in section 1, which is compulsory, which you have to attempt, okay, and section 2, section 2, you know, there are 6 questions, and out of 6 questions you have to do 4, so it's optional, okay, so which carries 10 marks. All right, so now without much delay, let's begin with chapter number 4, refraction of light through plane surface. Okay, now again in this chapter, the entire chapter is divided into 4 parts, A, B, C, and D. Okay, so these are the topics, main topics, okay, major topics that you have to study in this chapter. Now, in unit A, okay, the first portion of the chapter, you have to learn about refraction, laws of refraction, and refractive index. So you have to learn 3 things in unit A. Then you have to learn about prism and refraction through this prism in unit B, and you have to learn about application, okay, that is uses of refraction of light, or where or how you can apply in our day-to-day life, okay, the concept of refraction, that has to be learned in unit C. And in last unit, that is unit D, you will be learning about critical angle and total internal reflection. And this total internal reflection is a very important topic, because with this nowadays the communication has become very fast, okay, and that communication totally rely on this concept called total internal reflection. All right, okay, so let's begin now. In class 9 you have learned about reflection, isn't it? Now here see that we are learning about refraction, so it's a new topic for you all, refraction. All right, so before we go to refraction, let's have a quick recall of the thing that we have done in class 9 in your part 1 book. Okay, in class 9 you have learned about reflection, okay, you have learned about reflection. Now what is reflection? Reflection is the bouncing back of the ray of light after striking a polished surface or a reflecting surface like mirror, isn't it? Yes, so whenever a ray of light, okay, is striking on a polished surface, it gets reflected back, okay, and we draw normal here, okay, and it obeys, okay, this reflection obeys, okay, 2 laws, okay, light rays, the reflection of light rays obeys 2 laws, okay, and those are the angle of reflection, that is angle I, is equal to angle of reflection, that is R, isn't it? This is the first law that you have learned. And the other law was the incident ray, okay, suppose this is A, O, B, and N. So here AO is the incident ray, okay, the reflected ray, that is OB, and the normal, that is ON, they all lie on the same plane at a same point, that is point of incidence, okay. Okay, now let's again see the speed of light, okay, in different media. So now you know that light travels, okay, much faster as compared to sound, okay, and light can travel even in vacuum. This we have learned in our part 1 book, isn't it, in class 9. So now what is the speed of light? Speed of light is 3 into 10 to the power 8 meter per second. This is the speed of light, okay, in vacuum, okay, as well as in air. All right, but in water the speed of light is 2.25 into 10 to the power 8 meter per second, okay. So this is your vacuum or you can say air, this one is for your water, okay, and 2 into 10 to the power 8 meter per second in glass. So you can see that the light travels fastest in vacuum or in air than that is and with the speed of 3 into 10 to the power 8 meter per second. All right, so now if you see here, see, now why I wrote these 3 speeds of light here is just to make you all realize about the density. So here you see that I have taken 3 different medium here. One is water, one is air, and the other one is glass. If you compare these 3, you'll see that glass is the most denser and air is the least denser here among these 3. So here you see that less is the density of the medium, faster is the speed of light. More is the denser. Here you can see the speed of light is lowest, that is 2 into 10 to the power 8 meter per second in glass. Okay, जुन चाहिँ मिडियमको चाहिँ डेन्सिटी हाई छ त्यहाँ चाहिँ स्पीड अफ लाइट के हुँदो रहेछ, कम्ती हुँदो रहेछ. द्याट इज व्हाट आई एम ट्राइङ टु एक्सप्रेस हियर with these 3 speeds of light. Okay, so here now you got the idea that the speed of light, okay, increases with decrease in density of the medium, and speed of light decreases in a medium, okay, sorry, increases in a medium with a decrease in density. That is, it travels faster in less density, okay, of a medium as compared to the medium which is more denser. All right, now let's come to the main agenda of the class today, that is refraction. So now let's see here, let us read this paragraph here. When a ray of light is traveling from one transparent medium, so here you see all the 3 mediums that I've taken are transparent. That means light can easily pass through them. That is air, water, and glass. So when a ray of light is traveling from one transparent medium, strikes obliquely. Now what is obliquely? Obliquely means which is not parallel, okay, to the medium. For example, suppose say this is your water, okay, water in the ocean, or you can write sea, and this is the surface of the water. So if ray of light is traveling in this way, they are parallel to each other, means will this ray of light enter in the water here? No, isn't it? So the water, the air, the ray is traveling in the air here. It's not entering to the next medium, that is water here. So whenever, now here the situation is that when a ray of light is traveling from one transparent medium to another. So if I take the example of air and water, so here what is happening? The ray is traveling from air to water, but it is not obliquely, means it is not parallel, means it is making some angle here, okay, striking with some angle here. So at the surface of another medium, a part gets reflected obeying the laws of reflection, okay. So if I have water here, okay, and this is my air, both are transparent. So if a ray of light is striking on the surface, this is the surface which is separating air and water, what happens? A part of the light gets reflected back to the same medium obeying laws of reflection, okay, which is called as reflected ray. This ray is called as, okay, reflected ray, okay, and the remaining part of light enters into another medium. So it enters into another medium. So air bada aba kaha gayo? Water. So it's entering another medium and travels in a straight path different from its initial direction. So पहिला को direction त यस्तो थियो light को, isn't it, when it was traveling in air, but now it has changed the direction, and this ray which has changed the direction is called as refracted ray. Okay, so don't get confused between reflected ray, reflected चाहिँ same medium मा वापस जाँदैछ, whereas refracted चाहिँ अर्को medium मा गएको ray लाई चाहिँ के भन्छ? Refracted ray. Okay, so when a ray of light gets reflected back or bounces back in the same medium, it is called reflected ray. But when a ray of light enters from one transparent medium, here I've taken air, to another transparent medium, that is water, this ray which is in the another medium is called reflected ray. So this change in direction or path of light when it passes from one transparent medium to another transparent medium is called refraction. So यो चाहिँ भयो हाम्रो refraction. So what is refraction? the change in direction of path of light when it passes from one transparent medium to another transparent medium is called refraction. So now we got a concept here that whenever a ray of light is traveling from one medium to another, एउटा medium in another medium, from air to water or from water to air or from air to glass or water to glass to air or glass to water or water to glass, त्यति बेला चाहिँ के हुँदैछ, the medium is changing. Light is traveling but the medium is changing. Okay, so light is traveling from air to glass, so air देखि glass मा जाँदैछ, so there is a change in the medium. So whenever there is change in the medium, the light, okay, in the second medium does not travel in the same direction as it was traveling in the first medium. So there is a change in the direction of the motion of, or sorry, the path of the light. Okay, though it travels in a straight line path in both the medium, but the direction gets changed. All right, so this phenomenon is called refraction. Yo phenomenon la चाहिँ हामी के भन्छौं, refraction भन्छौं. Why does it happen? We'll learn in the upcoming topics. For right now, we just understand that there is a change in the direction of the path of the light when it passes from one transparent medium, or we can say transparent medium la we can say optical medium also. Okay, LI optical medium also we can say. So when it passes from one optical medium to another optical medium, this phenomenon is called refraction of light. Okay, now let's see what happens when a ray of light, or how this change in direction takes place when a ray of light is traveling from one medium to another medium. Now let me take one a surface, okay, S dash. This is a surface which is separating the two media. Okay, let the medium be air, media be air and glass. So if you see here that air, if you compare air with glass, okay, air is much more rarer as compared to the glass. Means glass is more denser as compared to air here. Now let me drop a ray of light, okay, A O, striking on the surface S dash at point O. So point O is the point of incidence. So from there I will draw a normal. So I have drawn a normal, and the name of the normal is NM here. Alright, so here you see that the ray of light, okay, if I have to follow the direction of AO, I see that the direction of path is in this way. Alright, but you see that we have learned that there is always change in direction, okay, of the path of light when it passes from one medium to another medium. So here you will see that when the ray of light is traveling from air to glass, that is rarer to denser, it bends towards the normal. The normal को छेउमा आउँछ. Okay, normal पट्टि चाहिँ ढल्किन्छ. So when this happens, when the ray of light is traveling from rarer to denser. All right, are you getting my point? So this is how the change in direction of light takes place. Clear? Now if we do the reverse of this, if the ray of light is traveling from denser to rarer, so if I draw a surface S dash which is separating glass with the air, so here now the ray of light is traveling from denser to rarer, that is from, okay, glass to the air. And if I draw a normal here, this is my normal, this would be the original path, okay, direction of the path of light AO. Now at this point what happens, the light is traveling from denser to rarer. यहाँ माथि चाहिँ के हुँदै थियो, the light was traveling from rarer to denser. So when a ray of light is passing from rarer to denser, it was bending towards the normal. But now here, when this ray of light is traveling from denser, that is from glass towards air, that is rarer, the ray of light will pass, okay, in the second medium and will be away from the normal. Are you getting my point? So it is now going or moving away from the normal. When this happens when the ray of light is traveling from denser to rarer. Rarer to denser मा जाँदाखेरि चाहिँ it is bending towards the normal. Okay, denser देखि, okay, rarer मा जाँदाखेरि चाहिँ it deviates or it changes direction, which is away from the normal. All right, now third condition or third thing we can see is that if I have the surface S dash which is separating the two media, let me take the medium as again as air and glass. If the ray of light is normal, it is making 90 degree to the surface which is separating the two media, then it passes to the second medium without changing its direction. So please note this down properly. So when a ray of light, okay, is passing from one medium to another medium, whether it is from rarer to denser or denser to rarer, if the ray is incident at 90° to the surface which is separating the two media, what will happen? The ray gets, okay, passed in the second medium without changing its direction. Alright, so this is what we are going to learn today. We are going to stop here. Before I stop, I'll give you some assignment. Okay, assignment number 1 is to write about refraction. So question number 1 will be, what do you mean by refraction of light? Okay, number 2, okay, what will happen to the ray of light when it passes from rarer to denser, okay, medium? Question number 3, what happens to the ray of light when it is passing from denser to the rarer medium? And question number 3, what happens to the ray of light when it is passing from one medium to another medium, okay, which is incident normally to the surface separating those two media? So these are the 4 questions that you have to submit me today in the evening. Alright, so that's all for today. Goodbye.